We made it through the first chapter. Congratulations. We are all finished with working on limits. Now, I should be saying we're all finished lecturing about limits. Limits are a tool that we are going to continue to use throughout our calculus journey or our calculus career, if this is something you're taking for your major. We're going to move on to chapter 2, which is the definition of derivatives. I want to pause a bit to talk about the kind of intuition that guides my understanding of the derivative. It's new stuff, and I find that it's very helpful to have this idea in my head as I'm learning new techniques and new ways of working on math problems. So take for a moment, let's imagine you are sitting in your car. Maybe you have a car. Imagine that you have a car. Now, most cars today come with 3 devices in the dash panel that I'm going to focus on. And those 3 devices are, number 1, the speedometer, tells you how fast you're going. Number 2, the odometer, tells you how far you've driven the car since the day it was made. And number 3, the clock radio. Music is fun. We'll get back to the music later. But for right now, that's going to tell us what time it is right now. The things that these devices measure are related to one another. Speed is equal to distance divided by time. Now, let's suppose that the speedometer on your car breaks, and I can no longer just look at the dashboard and know how fast we're going. Because speed is equal to distance divided by time, we should be able to figure out how fast the car is going based on just the odometer and the clock radio alone. Those 2 things should get the job done. It might not be the most practical solution. Our car won't really be roadworthy as long as the speedometer is broken, but we can make do. Now, I can't just take my odometer reading and divide by the current time, right? Maybe my odometer is like 1,042, and it's 1 o'clock in the afternoon. Am I really going 1,042 miles per hour? That doesn't seem like the right calculation I want to make here. But if we measure the time and the distance, we wait a little bit, we measure the time and distance again. We'll have 2 data points. And that will let us make an estimate. So this is actually something you can do at home, although I recommend you tell your passenger to do this. You keep your eyes on the road. Have your passenger look at the odometer and measure exactly the time it flips over to a new mile, and write down the time. So maybe at 1:03, our odometer flips over to the next whole mile. And what your passenger is going to do is they will watch that odometer until you have gone another full mile, and you write down the time again. So maybe at 1:15, you've progressed another full mile. What does that tell us? We have gone a distance of 1 mile in a time of 12 minutes. So this won't be exactly the right speed, but we can guess that we're traveling at about 1 mile per 12 minutes. Now, you might want to convert to miles per hour, and we can do that kind of unit analysis, but the key thing here is that we can estimate that speed based on how far did we go divided by how much time it took. Now, let's take a look at that in terms of the graph of a function.